Yo, what's up, V? You want me to hack into what? All right, bet. Let's do it.
All right, so V wants us to hack into his professor's new app they worked on. He sent me the IP address, which you'll probably see in the bottom left corner. So let's go ahead and throw that IP address into our host file so that we don't have to remember the IP. And to do that, we'll do a sudo nano etc host and then enter in our password. And then as you can see here already, I have the IP address and I've given it a name. So that way we don't have to reference the IP address anymore. We can just start referencing the name of it. Makes it a lot easier to remember. So we'll go ahead and save that and exit. And then let's go ahead and ping the name and see if we get anything back, meaning can we reach it? Looks like we can. Let's go ahead and do some recon, see what ports are open on this IP. And to do that, we're going to be doing it with nmap. Now we can run nmap, and here are the flags that I've used for this. And I'll show you on the screen what each of these flags do. I go ahead and run that, and our nmap finished. All right, let's take a look. So the two ports that are open are 22 and 80. One is SSH, the other is HTTP. And it looks like the HTTP title is the weighted grade calculator. And that's run on Linux. Awesome. So let's clear that. And let's actually just curl the header and see what we get. Okay. We get a server on WebRick 1.70, which is run on Ruby from 2021. Very interesting. All right, since we know all that, let's go ahead and just open it up in our browser and check it out. So let's go here, run perfection. The proxy server is refusing connection. Oh, that's right. I need to run Burp Suite. Let's go ahead and run Burp Suite. Start that up. And then we can go back to our Firefox, hit enter, and there we go. We get the weighted grade calculator, a tool to calculate the total grade in class based on category, scores, and percentage weights. Very interesting. Powered by WebRick 1.7. Okay, let's check out the About Us. Tina Smith, web developer, our team, computer science. That's good to remember Tina Smith because we may be able to get her credentials. Susan Miller, that's the professor that V mentioned. Professor of computer science. Okay, so that's another good name to remember for being able to get some type of credentials going forward. So let's click here, calculate your weighted grade. And from here, let's just start messing around with this. Let's go test 1, grade 1, weight 1, test 2, test 3, test 4, and just enter all these in. And then submit. Please re-enter. The weights did not add up to 100. Okay. Let's go back. And let's just change this to 100. And we'll change that to 100. Everything else can be 0. We did really well in one test. We just bombed the rest of them. Go ahead and submit that. And it looks like that worked out. So we did get that working. So it looks like we do have to play around with those. Okay. So we'll go back to that. And then we'll go into Burp Suite. Go into the proxy and click on the intercept. That means that we're going to be intercepting the request that we send through Firefox when we click the submit button. So let's go ahead and submit it. You can see here it's stalling. So we'll go to Burp Suite, and now we've intercepted that. So let's right click, send that to repeater. Repeater is something that we can just continuously repeat on sending this post request with this data. So I'm going to forward that just so I don't leave it hanging. See it still works, and then go back into Burp Suite, into the repeater. And now we can see in this one tab that we have that. So let's go here and just change the weight from 100 to 1000. Let's see what that does. All right, let's take a look through the code. Please re-enter. Weights did not add up. We could also render it. That's probably a lot easier. Please re-enter. Weights did not. So we can't do that. Maybe the grade. Let's change the grade to 1000. See what that does. Send that. Okay, that's something new. Malicious input blocked. So it is blocking inputs. The other thing to test is probably most likely going to be the category then. We could start testing different things in the category. Let's see, like, what if we did 100%? What happens then? Okay, malicious input block. So we're going to start messing around with the category. We can do a number of different things, like using fuff and fuzzing it and throwing a list of random characters to see what filters or what works, so forth and so on. Long story short, I went through the process of seeing what works. So I'm going to just go ahead and show you, because the purpose of this video isn't to test out everything. It's just to get you the basics to get through this. The new line is the thing that's able to bypass the filter, the malicious input for this app. So let's go ahead and try it out. I'll show you by writing neo and using the URL encoded for the new line, which is %0a. And let's go ahead and send that and see what happens. Okay, so we did get a 200 back. And let's scroll down. And it did go through, so no malicious input. And we could see here Neo and Neo new line and the 100% underneath it. So it looks like the new line is where we can start entering in a number of different inputs. Maybe we can do, let's see, a percentage sign was what didn't work last time. So let's do 100% this time and see if that works. Getting back a 200, and it looks like that's still working. So Neo, new line, 100%. So it looks like we have a number of different ways where the new line operator, which is URL encoded, is how we can bypass that filter. Before we do the reverse shell, let's take a look to see if there's any SSTI injections possible in this. And remember, going back, we noticed that it was built on Ruby. So let's go ahead and search for SSTI on Hacktricks, which I've already done. Server-side template injection. And I did look up SSTI, and then I searched for Ruby. And over here we could see a number of different ways that we can test it. So let's just copy this one, and if it works, it should output 49. So let's see what that does. We'll just throw that in there, and just to be safe, let's go ahead. Let's run it without URL encoding, see what it does. Okay, doesn't work that way. Let's URL encode it. I did that by pressing Control U. It's a shortcut on Burp. And it looks like that worked. Looks like that didn't work. So what did I do wrong? I think I encoded it incorrectly. Control U again. Yeah, I must have URL encoded the and sign. Okay, so we're getting back at 200. Okay, let's scroll down, and there we go, a 49. So we do have SSTI, server-side template injection. Now we can start crafting our reverse shell, since we know the new line operator, the percentage 0A new liner, is able to work with the SSTI, the server-side template injection. We can go ahead and replace this 7x7 with a reverse shell. So let's go ahead and do that now. All right, back into our terminal, and let me just go into my folder for this, HackTheBox at perfection. Okay, and here we're going to base 64 encode a reverse shell to our IP address with a port. Now you can see up here in the top right, that's our VPN IP address, and that's what we need to run netcat, and we'll do port 1234. We'll go ahead and open a new window and cd into our folder as well, and then here we will base 64 encode our reverse shell with our IP address in our port. And this section here is where the base 64 will sometimes input a plus sign. We're actually just getting that removed, so it encodes correctly. So we'll run it that way, and typically the plus sign will be in here. That will throw us some errors that we don't want. And we'll copy this, that's our base 64 reverse shell encode, and then we'll go to Burp Suite, and then in Burp Suite, let's see, we'll go here in category 1, we'll do, let's see, 3D system, and then we will echo plus sign for space, and then we will copy the code that we just base 64 plus sign pipe. All right, where's my cursor at? All right, and then base 64 plus, and then D for decode plus another plus bash, and then we'll end quotation, and then all right, so this right here is essentially our reverse shell. Okay, I'm just gonna copy that just to have that, and then we have the new one friend. That can be anything, that could be random text, and then we have the new line operator that's able to escape the malicious input. In this case, it's allowing us to execute this reverse shell here in the category 1. So we're going to go and test this, send it, and so we're not getting a response, which that's a good thing. That means it's stalling. We go over here into our netcat, and we have access to Susan's app now. Who am I? I am Susan. We could check ID, and there we go. So we got into Susan's app. Before we run any other commands, we do need to upgrade our reverse shell, so that way we can Control C without actually closing out of our reverse shell, and we can also clear the screen and have some colored output as well. So we'll go to the next pane, and I'll do a breakout, and I just have some notes here that I typically have saved on my Linux. I'm just going to copy this, go back, paste it, hit enter, go back, and start just copying these lines here, and there we go. Get some color, export term, copy paste, enter. I'm going to skip the alias, and then I'm going to Control E, copy, hit enter a few times, and now I can clear. I can Control C without it actually closing the reverse shell, which is awesome. And then I have some color in my output. So now that we're here, let's go ahead and CD into the home folder, and let's take a look at what's in the user text. And we got Susan's user flag. So if you're following along with me on HackTheBox for the perfection, here is the flag that you get and submit. So let's clear that. Next thing to do, let's see, I think we came in at the Ruby app. So let's check out migration, and let's see what's in there. And it looks like there is a database there. So that's awesome. So let's do file pupil credentials database, and then we can run that and see what that is. And that's going to be an SQL3 database. Okay. So let's go into it. SQL, let's see, Lite, I think it was, or was it SQL Lite 3? Then go into the database. It looks like that worked. And then let's check if there's any tables. In this case, there's one table with users. That's very promising. So let's select from users, and we will select, and the stars select everything from the users table. We'll get that. And here we go. We get a bunch of different names. So that's Susan's name, Tina's name, Harry, David, Stephen. So we can go ahead and just copy all of this and go in here, clear nano Susan hash, and throw those in into a file. I've already done that ahead of time. And we can start figuring out how to break these hashes, how to get Susan's password. So let's clear that and go back. Let's see, I think it was Control D was how to get out of the SQL Lite 3 database. And let's clear that. And let's look around to see if there's any other information that will help us crack Susan's hash and be able to get her password. So let's see, we're gonna go outside the home. Let's see, go into the Linux. Let's check out the temp folder. Maybe there's something in there. In this case, I'm not seeing anything useful. Let's clear this and go back. Maybe let's go into the var and see what's in here. We get backups. Let's look in backups. Okay, we got a number of different backups, all gzipped or tarred. I don't really want to look through all that. Let's not rabbit hole too badly. Let's see, what else can we look at? I'm kind of interested in the mail. Let's see if there's anything in there. There is a mail for Susan, and here we go. So we got something. Due to our transition to Jupyter grades because of the pupil path data breach, I thought we should also migrate our credentials, including the other students in our class, to the new platform. I also suggest a new password specification to make things easier for everyone. The password format is, okay, here we go. This is great. First name underscore, first name backwards underscore, and a randomly generated integer between 1 and, what is that, 1 billion? So, okay, so this piece of information here is very helpful piece of information to be able to use this in order to crack the database the hashes that we got from the databases. All right, now back on my Kali Linux. So taking the information that we had, let's actually run, what can we do? Let's run name that hash on Susan hash. Right, let's cat Susan, and we're gonna take this hash and we're gonna run it with name that hash and see what it gives us. Okay, name that hash gives us a most likely for a SHA 256 1400. Okay, so now that we know that, let's go ahead and try that with hashcat. I'm going to clear the screen and I'm going to just work on Susan because she's the one in charge, I think. I'm going to copy her hash and I'm going to nano Susan hash.text. I'm going to throw it in here just by itself so that we can start working with it on hashcat. Now next is hashcat mflag 1400. We're going to use Susan hash.text and then we're going to do a flag 3. Now this part is where we're going to use the information that we gathered from the email. We're going to do quotes Susan, her first name spelled correctly, and then her first name spelled backwards, followed by the mask that we need to use for the integers for hashcat. In this case, it's $D. And we need to do that up to an integer. I believe it was 1 billion. So we need to throw 9 D's in there for this mask. So we got 1, 2, 3, 4, 5, 6, 7, 8, 9. So now we got the mask for Susan up to 1 billion. Now it's actually right under 1 billion. We're not actually going into the billion mark because we don't want to hit anything above 1 billion or 1 billion. So we're just gonna go and start running that. And it shows us that all hashes found. I've already ran it before in the past. So I already know what Susan's password is. In other words, I've cracked Susan's hash. But what I can do is I can, let's see, pot file disable just to show it on how it looks. So now what it's doing is it's running and it's working through you can probably hear my computer in the background going at it. So it's going through it, but I can hit S for the status and some more information will show up. But it looks like it cracked it pretty quickly, I think within a few seconds. So here's the guess mask that I've used, up to 21 digits. And here's the hash that we were cracking for Susan. And here is Susan's password that hashcat was able to crack with the information that we provided. So we can go ahead and copy this. So let me do that. And probably be best to save that somewhere in your notes. And what I'm going to do is I'm going to actually exit out of this reverse shell that I upgraded, and I'm going to SSH into Susan at perfection.hackthebox, and then I'm going to enter in that password that I was able to get, and now we have access to Susan through an SSH. So that's awesome. So after that, we can do a clear, and then let's do a sudo L, and then it's asking us for the password that we just used, and now we have sudo. So let's see here. Now that we have that, let's cd into root. Okay, Let's do sudo su. And now we are root. So we have root access now on Susan's computer or application, wherever this is. So let's go ahead and cd into root. And now we have the root file .txt. And there's the root. So we can copy that and submit that to the HackTheBox for perfection. All right, so now that we have root access to Susan's app, I'm sure V would be pretty happy. If you guys enjoyed this video, give me a thumbs up, subscribe. If you have any questions, throw them in the comment section below. If you guys want to see more of these videos, let me know, and I'll see you guys in the next video.